All right, good morning, good afternoon, or good evening. Welcome to the fourth Excelero webinar of 2020. For this webinar, we did not invite any partners, customers, or other guests. Today, it's all about us, more specifically about NVMesh, the past, and more importantly, the future. For this unique webinar, you will be in the good hands of Yaniv Romem, founder and CTO at Excelero, one of the smartest and most enjoyable people I have had the pleasure to work with. Yet again, we've got a very mixed audience, which promises to result in very interesting Q&A at the end of the webinar. To make sure we're all on the same page, Yaniv will kick it off with a bit of an NVMesh overview, but very soon he will dive into what you're all eager to learn. What's next? What is our engineering team working on? Why is NVMesh becoming the most popular choice for GPU storage? Why are we growing so fast in the AI market? Before I hand it over to Yaniv, here is some logistics information. In a way, this webinar is a follow-up to our State of the Storage Union webinar last month, in which we got so many great questions about NVMesh that we decided to give you folks the opportunity to ask away to our CTO. So we expect this webinar to be very interactive, and we would like to get as many questions from you guys as possible. And this is how this will work. Everybody but Yaniv will be on mute. And at the bottom of your UI, you should see a Q&A button. Post as many relevant questions as you want. We have, during the webinar, a team of specialists ready to answer the questions real time. And we will answer the best questions live, or at least Yaniv will answer the best questions live at the end of the webinar. With this, Yaniv, the floor is yours.
Thank you very much, Tom. Thank you for the intro. As Tom said, I'm Yaniv Romem. I'm Chief Technical Officer for Excelero. My pleasure to present to you today. I've put up here just for, as Tom mentioned, as for some background, a little bit about who we are and what we're doing, and some basics of the company. Maybe I'll even put as a prelude to that, you know, our raison d'etre, as we like to call it, or our reason for being, is really to help people out there, help people really get free of having to worry about their storage and the performance that their storage brings, to be able to bring them a solution that really relieves them of having to worry and struggle with, you know, how do they plan out their storage, because it'll be so efficient that they will literally not have to worry about that anymore, and they'll be able to focus on other areas instead. And for that purpose, we founded the company back in 2014, around mid-2014. Our headquarters were set up in Tel Aviv in Israel, but we've branched out and we have offices today in the States, in the Valley, and in Germany. We have about 50 employees. The large bulk of them are engineers. We're a very technical company. And so most of our folks, whether they're in sales or marketing, but also in development, of course, are mainly engineers. To the extent of being able to bring this vision to fruity, to actually make everything happen, we've raised $40 million to date. A little bit about our technology at the prelude, but we'll be talking about that mainly as we go forward. We provide a software-defined solution, so we're not trying to tie you into any specific hardware. And what we really want to do is be able to give you something that feels like NVMe, that has that kind of performance envelope, that kind of latency with it, and provide you a real storage system that has that kind of performance feel, such as NVMe, but make it as elastic as possible, so that you can start it out as small as you like and grow it and grow it and grow it as your needs grow, and as you become confident in our solution. As part of what we do, we're doing very groundbreaking things. We've been filing for patents. We already have 10 approved issued patents in the storage and the networking space, which we're very proud of. From a go-to-market perspective, and this, I think you'll see this in our product offering as we talk about it as we go forward, we really address two different markets to some degree. So we have a lot of, and this is also people who know us from, you know, from previous experience know that we have been very successful in the directly selling into some of the larger companies in the world, what we like to call the hyperscalers. Our offering, being a data center scale kind of solution, is very well tuned for them. Another couple of domains, and one of them we'll talk more in depth on today, where we do a lot of business also, is via our partners. We have a wide range of partners nowadays that we like to work with, as they provide a lot of added value as we go into customers. Through our partners, we've been able to work and help people who are working on AI, artificial intelligence, and to help them accelerate their database access. With that, a short recap for those who are not familiar perhaps, or just to make sure that everybody's on the same page from what we offer. So our main product is called NVMesh. Excelero NVMesh really does build an elastic pool out of your NVMe. So you provide NVMe hardware, or you have NVMe hardware in your data center. It can be put on standard servers. I'll even call them commodity, but it's really off-the-shelf servers. Nothing really commodity anymore about hardware nowadays. Everything is really state-of-the-art from a technological perspective. But you can take standard servers, you deploy them with NVMe. They can be dedicated storage servers, or they can be part of your compute facilities. And you put in NVMe drives. And when you put our solution on top, you turn it into an elastic pool of NVMe. That pool is then a basis for carving out logical volumes. And I'll talk more about what those logical volumes, what they really hold. But they are things that you can then go and provide to compute nodes in order to use as their virtual disks or virtual drives or virtual NVMe drives. Why do we keep on using the term NVMe? A, because it's great technology and we love to have it underneath, but also it represents the kind of performance envelope that we are really so proud that we are able to provide through our virtual volumes, logical volumes. What are we providing at the end of the day? We're providing a standard block device that looks like a local drive, but it's actually implemented across this elastic pool of NVMe. And on top of that, you would typically want to run a file system. Some people use it for object stores, some put databases directly on top, but most of our customers end up putting some form of file system on top. Being a generic block solution, even though the volumes can be shared across multiple, the same logical volume can be shared to multiple compute nodes. At the end of the day, you either put a local or distributed file system. And we'll talk a little bit more about how that flexibility is so useful in various use cases as we go forward. From a virtualization perspective, so we're taking physical NVMe and we're transforming it into virtual NVMe in a way through our logical volumes. And they're very, very elastic in the sense that you can start with a really small volume. You can go and say, I'm running microservices. I need very, very small volumes as low as 1 gigabyte. And then you can carve them out to that size, or you can make them much larger. We have customers who have multiple volumes, even thousands of volumes in their environment of a very small size. And we have customers who take all their NVMe and pull it into one very, very large logical volume. But what is common to that is no matter what size you get, you really do get NVMe-like performance. One other thing that is really important that we provide in our logical volumes, and again, we'll go into more detail as we go forward, is we provide data protection. It's no longer just a local device. Data is protected at a data center level so that you can feel confident that your data is being protected if you choose to do so. One other thing that is very, very unique about NVMesh is that it has a distributed architecture. And this distributed architecture that is patented to some degree means that you can scale out your system. You can, again, start from a really small size. Today, you can even start with a system as small as just one storage server and grow to thousands of storage servers. The way that we enable this is by having removed all the controller bottlenecks through this distributed architecture. If you feel that your controllers, the front ends of this environment, are becoming your bottlenecks, you can always just add in more. And in that sense, we've really removed the controller bottleneck issue that hampers a lot of distributed systems or a lot of storage systems. Our data protection also is distributed, which means that we're not keeping multiple copies of data or doing erasure coding only within the confines of a single box, but we're actually spreading the data out onto multiple boxes. So you get what is sometimes called a RAIN solution, redundant area of independent nodes, not only independent drives. And that's really what helps bring our system to have what's called data center protection or data center quality protection, and makes it really resilient to failure. And the way we've been able to achieve the combination of performance and resilience is by integrating with the network. We work very closely with the networking companies in order to really minimize the overhead of sharing data across a network. And essentially what you get from a performance envelope and from a look and feel of the volumes from a performance perspective is that local performance and remote performance, you don't even know whether the drive is local or remote. You're getting extremely high performance, really low latency, that is very effective. One other point, final point on this maybe, is that we do internal multipathing to make sure that everything is flowing well and that you can be fault resilient also from the networking perspective. And then finally, and we'll talk more about this later on, we provide multiple networking options so that you can really run this on any kind of network to the in the best way. So talking just a little bit more about sort of where we are as a company. The company was founded, as mentioned before, in 2014. Within a couple of months, we came out with our first alpha where we demonstrated our RDDA technology, which is a core of everything that we do, or a core of a lot of the things that we do. Remote direct drive access, which basically means we know how to go through the network and fetch data from a remote drive without actually having to run any code for the data path on the target side. It took us about a couple of years to turn this into a real product, turn that POC kind of capability into a real product. And even before our beta came out, we've been working with some of the hyperscalers to really refine and understand what is the best way to bring our product to the market. And we were able to get our first customer served already, even before the product was GA. And there are some companies mentioned here, some of our customers. We are mentioning those that we have the right to actually talk about publicly. There are many other customers that we just don't mention because because of restrictions around publishing their name and all. So don't take this as a list of all our customers. We have tens of customers, or even maybe close to 100 customers nowadays. We launched the company back in March 17. We did a large tech field day and released the first version of NVMesh to the general public. We went GA with the product a few months later, our first really generally available version of the product. And then in March of 19, we came out with what we call our first data center quality version, which really can scale to large sizes, even from a data center perspective. Sorry, had the quality, so it had the data distribution that it can really work well in a data center environment, and people could take it and deploy it with very high confidence in its performance, but also in its reliability. Late last year, we produced a version called 1.4, which we didn't actually make generally available. So if you look into, if you do searches on it, you won't find this product. It's a product that we took to a select number of data centers where they wanted to test our product not only for its quality, but also for its scale. So we had some hyperscalers literally deploy this on thousands of clients within a single namespace, and it helped us really develop our technology in a way that made it not only have a scalable architecture, but with this, we were able to bring the scalable architecture to a real product. And that's what this 1.4 hidden version was about. As we progress to 2020, so we came out early this year with our 2.0 version, which had a very major new feature called erasure coding or distributed erasure coding. High performance distributed erasure coding is probably, this solution is probably by far better than any other software-based or any other scalable erasure coding solution. As mentioned before, it can be deployed across a wide range of nodes in order to make sure that the data really is protected, even across node failure, even across rack failure. You can literally distribute the data as fits your data center. But you can, again, start from a really small environment. You can start from a single box and then grow as your environment grows. And I will go into more detail on the various features of the releases that we plan for the remaining of the year. I will mention that all of this is a plan, and as we're a flexible startup, plans do change. And so all of these, especially the dates, should be taken with a grain of salt, but this is our current plan that we're sharing with the public at the moment. We expect to release our version 2.1 later this quarter, and it will bring TCP. As I mentioned earlier, we now have the option to do TCP in our product as well. It also comes with integrated NVMe-of, which we now have in our product as well. Both of these features have been demonstrated, and we've worked closely with customers for, and with this version, we are making them more generally available. Later this year, we have a version that's coming out that is more tightly integrated with AI. And I'll talk later about how NVMesh works with AI and what those integration features look like in more detail. And then as we progress in the year, we are coming out with more extensions to our erasure coding. So initially now we're coming out with 8.2, but throughout the versions that we're just releasing over the year and early into next year, we will be optimizing and extending our erasure coding. So with that, I'm going to take a little bit of a skew and talk a little bit about how NVMesh is being used for artificial intelligence. As a starting point, just a little bit of background about how artificial intelligence is being used today. So everybody's, a lot of people are talking about artificial intelligence. There's a lot of hype around this technology. It's bringing a lot of value to businesses in various different areas. But the key to all of it is the ability to go and have very, very large data sets, or often you need very large data sets that are clean and prepared, and then put into what are often called training sessions to generate models that can then be used to go and predict things, or in that way, their ability to go and predict or evaluate new data that comes in is really considered the artificial intelligence. As an example, the most commonly used examples are, let's say I want to be able to take pictures and differentiate whether I see a cat or a dog. And I apologize if I'm using the most common example and I'm boring people in that sense, but it's the one that's probably easiest to understand. So I have a huge database of pictures of cats and dogs, and I use this to go and generate or train my model until eventually it really knows well how to differentiate between cats and dogs. And now I can bring it new pictures of cats and dogs and let it automatically decide which I'm using. In order to make these data sets, in order to make these training sessions efficient, in order to generate models that have a good prediction quality, I need to really work with large data sets. And what we're seeing in the market is that as people increase their data set size, they are often able to get better and better prediction quality, which is critical for the artificial intelligence to actually deliver on its promise. For that, to work with those large data sets and to be able to train and generate good modules, AI infrastructures we're seeing them grow in the market. We're seeing them double up way faster even than within a year. We're seeing numbers like, they're doubling up every 9 months or so currently from a compute perspective. So how do you make these infrastructures scale, and how do you provide them these ever-increasing larger data sets, and how do you keep things going fast so that the data scientists who are trying to improve their models really have almost interactive sessions to be able to really improve their things? That's sort of where NVMesh comes in, is really helpful for that. What we hear from the community is that, or from our clientele, is that storage performance is key. And in order for storage performance to really match as you grow and you scale, you need to be able to start out from something that's really small. Even from a small amount of storage, you need to bring somebody a solution that they know can grow with them and provide them the price performance benefit that we provide already from the smallest scale, even for just a single GPU or AI server, all the way up to maybe a data center that has multiple GPU servers and is running very large data sets. One other aspect that I'll already point out here is that there's a lot of discussion around, okay, so what file system do I use? How do I keep my data? In what form do I keep my data? And for here, I think we're coming with an answer that is actually somewhat different than what other storage vendors are talking about. We're not saying there's a one-size-fits-all. There are many various different types of artificial intelligence or various different types of problems that AI is handling. And there are various different phases within the AI workload: cleaning the data, training it, then using it for inference, the models that are generated out of it. And for these, we have actually suggestions for different types of solutions from a file system perspective, depending upon what your data access pattern looks like and what your actual needs are. And what we're doing is we're eventually combining them under a single umbrella to really make it easy for the end user to decide what is best for them, or to be able to use the most appropriate technology for the problem at hand. with that, I'm going to take a short pause and let Tom run one poll. He has a question for you all.
All right, thank you, Yaniv. If my good friend Chris, oh, there we go. So quick polling question for us to get an idea of what you guys have in place as storage. All right, I don't think this needs to take much longer than this. Yaniv, you can go on.
Okay. So just a couple of more words on what is the right file system for the environment or for your choice of work. So if you look at a very small initial problem and say, oh, I can get all my data into my into a very small single file system, and I just have one GPU server or one AI server that's accessing that data, maybe I can just use a local file system. But then as you grow to more and more AI servers, does that still work? Well, you can't really share and read write into a local file system like XFS or ext4 from multiple nodes at the same time. So maybe I should start out already with a shared file system, such as BGFS or IBM Spectrum Scale. Well, maybe that's overkill for a lot of things. And maybe by using that for very read-intensive workloads, maybe I'm paying a very, very large penalty for having to access, to use a shared file system, which has a lot of overhead on it. What we're really saying is that you can go and you can generate a solution that is using a combination of shared file systems, local file systems, for instance, for storing your models from each GPU, from each AI server, and maybe using read-only local file systems to store large amounts of data that are mainly read. And for people who are interested in learning more about how we do this, we invite you to contact us after the webinar. Looking at the GPU server storage requirements just a little bit deeper. So again, we talked about, our reason for being is to go and eliminate storage bottlenecks and make storage not be a problem from a performance perspective. So how do we do that when we start looking at AI and GPU servers? So first thing off is that, often you find that you have NVMe inside your GPU servers. And instead of using the data only locally, you can actually, with NVMesh, you can pull them into a pool and be able to share that. That already extends the value of that data because now all the GPU servers can access the data from anywhere within your environment. So instead of having isolated islands of GPUs or GPU servers, you have a shared pool that they can all access. In addition, we let you add external NVMe to bolster up the amount of storage that you have. So you can literally just go and say, okay, I also want to take storage from this server or storage from that server and add it in and increase the size of your pool. All of this is done with minimal latency overhead. One of the things that we have found in the GPU workloads, to keep the GPUs running at full speed, they need to have high bandwidth and high access to a lot of data. But the latency is also very, very important. When you increase the latency, when the latency overhead grows, GPUs end up waiting for that latency. From a return on investment perspective, when we say that we're very elastic, we can start from a small size and grow to practically any size. What we find that the lead turn translates into is that you need to be able to scale your performance linearly. So if I'm going to buy 2 times more hardware, I expect to get 2 times more performance. And thanks to our distributed architecture, that's one of the things, and with our no single bottleneck, no single controller that is managing the entire environment, this is one of the things that our product really does do well. And one of the things that we found with our hidden 1.4 version was that when we scaled out to large sizes, this premise is something that we were actually able to deliver on. Another point on that is that it's very, very critical for GPUs to try as much as they can when they access the storage to minimize the usage of CPUs. There are new reference architectures of how to build a GPU server with multiple GPUs to get the most efficiency. And the CPU there can be a bottleneck. And we'll talk a little bit more about that also as we talk about a roadmap. Finally, everything that I mentioned has to support existing AI workflows. We're not trying to convince people to go and change their workflow in order to use our product. They can take our storage solution and bring it into their workflow and get immediate benefits. So how do we do all of this? And this is a recap to some degree of what we said before, but we provide software-defined block volumes. We can run them on commodity or to be more precise, off-the-shelf hardware. We provide the absolute state-of-the-art performance by leveraging NVMe drives and allowing you to get NVMe-like performance across the network. We do cross-rack erasure coding to really provide the highest level of data protection for your data center. We're very flexible in the way we can deploy the product, so you can take multiple GPU servers and combine them in a converged way and share the data, or you can put the data, you can put your storage on separate servers in a disaggregated mode, and you can actually combine the two. So that flexibility that is afforded by software and not being tied down to a specific hardware can help you as you roll out your system. We've gone to a lot of efforts, and this was one of the most important conclusions from working with the hyperscalers, is that it's not enough to have a great system, but when something goes wrong, you need to have great telemetry to be able to hone in and find exactly where the problem is. And we've done a lot of work around that. And finally, we've done a lot of integrations with orchestration systems, Kubernetes, OpenStack, and such, to be able to facilitate easy deployment, to simplify using our product for your environment. What's unique about what we do? So we literally let you run your application anywhere in your data center and avoid having storage bottlenecks as much as possible. The product is elastic, it's scalable, and it provides great price performance from the small size all the way up to the top. It's been heavily optimized for AI now. It's been optimized from day one really for hyperscalers. And we have some unique patented technology, which I mentioned before. Okay, so I'm going to start, instead of talking about the different versions, I'm going to talk a little bit about the different topics that we're addressing, and then sort of lay out how we're addressing them in different versions. So in the first one I'm going to talk about is the data protection and how we're making our erasure coding even better. So as I mentioned before, earlier this year, a couple of months ago, we came out with NVMesh 2.0, which really brings a new level of data protection to the market, available in a software-defined storage solution, highly performant erasure coding. You literally can get millions of IOPS from a single node with our erasure coding. It's extremely efficient from that perspective. And we give you a choice. So you can really mix and match different types of volumes within your same environment. You can go and say, hey, I need this amount of storage just for scratch. If it gets lost, it gets lost. That's not a problem. You can make volumes without redundancy. In the same environment, you can go and generate mirrored volumes, which we had in our NVMesh 1 series of versions, which provide you the absolute best performance, both for reads and for writes. But it had a 100% penalty from a capacity perspective. So you needed double the space in order to store a piece of data. With Mesh Protect that we've introduced in NVMesh 2.0 with an 8+2 layout, meaning that for every 8 blocks of data, there are 2 blocks of parity. You get much more efficiency from a space perspective. You get double the availability, because you can lose even 2 out of your 2 drives and still continue to function, but you do lose a little bit of write performance. So we provide that combination today. You can start out from a very small size and grow, and we're really giving what we call AI level performance, in the sense that the read performance that you get even from a parity-based solution is tremendous, and it can be sufficient for any GPU server in the market today. What we are doing in our upcoming version is taking that same technology and allowing you to have more flexible layouts. So you can then go and say, I don't want specifically 8 data blocks and 2 parity blocks. Maybe 1 parity block is sufficient for me. Maybe I want to be able to use a smaller amount of drives. So maybe I only want to use 4 data blocks. We're giving you more flexibility, as we've had customers who have asked for specific numbers that fit their environments and fit their needs in a better way. And by this, we're giving more flexibility. And as times goes by, we'll add more options for the number of data blocks and potentially also for the number of parity blocks within our erasure coding. And that's coming in NVMesh 2.1 already. In NVMesh 2.3, we expect to bring RAID 60 as well, which will allow us to give you even better performance out of the box with erasure coding. you'll be able to stripe across multiple protection areas, we'll call it. So if we have an 8+2 across 10 drives, and we actually want to get even more read performance than the 10 drives can give, we can add on another 10 drives and do both striping and erasure coding on top of them in order to provide a true RAID 60. And that will be integrated. There are means of doing it today with our product, but they require more configuration from the administrator. With this solution, we'll be able to make it even easier for the end user to use this kind of extreme performance with erasure coding. And with NVMesh 2.4, which should be coming out early 2021, we are taking a combination of regular flash, and it's funny to say, but slower flash, to talk about flash as a slower medium, but cheaper flash like QLC, and allowing and combining it with faster SSDs or even SCM, and providing a huge increase in the performance of the erasure coding on the right side, so up to an X2 write performance increase by combining these two, and also increasing the endurance of the drive. So that you'll be able to use QLC even in an artificial intelligence kind of environment, or even for some database loads, definitely for hyperscalers. And the combination of these two, the way we're building them will allow you to really get even better performance from our system. And the cost of it, because you're using a lot of QLC and a little bit of higher end or lower latency SSD technology, the combination will come out even cheaper than the current erasure coding that we provide. Tom, do you want me to take a short break for another poll, or should I keep going?
Go ahead, yes.
Okay. Okay, one other aspect that we are addressing is that our product comprises of a client and a target, and that combination gives us the ability to scale the system to a very large level and to provide the absolute lowest latency overhead. But for some environments, there are customers who have a hard time installing our client onto their compute nodes that they prefer to separate for all sorts of reasons, whether it's technical because we support Linux only, or whether they have nodes where they want to have a very tight control over the software run on top of them. And so they actually want to take their compute to be able to attach to our storage system only remotely. So for that, we're providing a couple of solutions. We already have, again, customers who have tried this out where we've done some of the integration by hand. What we're really doing here is bringing the integration under the umbrella of our management, so that you can literally generate a volume, expose it via NVMe-of through our management, and then have the storage system take care of it. And in that way, you can now be able to go and connect Windows or VMware environments into NVMesh with ease. You get everything, you can manage everything through our management system, so you have a single pane of glass for managing both your NVMesh volumes and their NVMe accessibility. And it makes it very easy to integrate because of the disaggregation. Again, it's not a one-size-fits-all. Many of our customers will continue to install clients on their compute nodes in order to get the best performance. And maybe some of our clients will only do this kind of clientless rollout, and probably other customers will do a combination of the two of them. But one of the themes that we're trying to show, and one of the things that has been really important for us from day one, is to show how software is so much more flexible than using hardware or appliance-based solutions. And this is just another great example of that. Another means that we have for clientless rollout is by integrating with SmartNICs. A little bit of background on SmartNICs. So SmartNICs are really network cards that have been enhanced by adding a programmable entity on them. Typically, that's a CPU. In this case, what we're showing here is a Mellanox Bluefield 2 SmartNIC that is expected to come to market in the near future. We're already working with Mellanox Bluefield 1 and with a similar product from Broadcom. These have ARM cores, and what we essentially do is we run our client. Instead of running it on the host, we run them on the SmartNIC itself and expose volumes using either NVMe or NVMe to the host. With the BlueField 2 specifically, we're leveraging a technology that Mellanox has come to the market with, something called Snap NVMe, which really means that you can snap a block device of any type, including an NVMesh device, and just expose it via NVMe to the host. And it really does look like a local NVMe device, with just one small difference. It's actually backed by a real storage system that provides it high availability, and it can make it shared among multiple nodes so that you can get the best solution that way. This allows also to build solutions on top of this, supporting multi-tenant environments, which the hyperscalers really like. So you can run different clientele, have access to their storage without having to worry about installing software on the guest OS or on the bare metal OS in this case. It also has a small benefit for the host CPU, as we can do the erasure coding calculations on the ARM core itself. I see a small benefit because to begin with, our erasure coding is extremely efficient and doesn't use a lot of CPU. But even that small amount of CPU, you can offload to the SmartNIC, which gives you even more benefit. Moving over to the AI side again. So how are we really helping with AI storage? What we have on the right-hand side is a reference architecture from NVIDIA of how to go and build a very clever GPU server with multiple GPU servers, multiple network cards, so you can go and have fast access to the network, and also multiple NVMe drives inside. Essentially, inside it has 4, you could even look at it as 8 different PCI domains, thanks to PCI switches. And essentially what you really have is you have a lot more PCI connectivity from the GPUs here than you have PCI lanes going into the CPUs. And the way storage typically is done today with GPU servers is that when a GPU needs to go and access a storage device, it talks to a piece of software from the GPU, talks to a piece of software on the CPU and says, hey, I need to go get this storage. Go do it for me, and let me know when it's in DRAM, and I'll go and pick it up from there. The problem with that is that the GPUs today are so fast, and the amount of storage that they need is the amount of bandwidth of storage that they need is so high that the CPUs themselves become a bottleneck. So if I can get 50 gigabytes per second through the CPUs, but my GPUs actually need over 100 gigabytes per second in order to be running at their most efficient level, that's just insufficient. And so NVIDIA have come out with a program called Magnum to go and improve GPU efficiency in general. And as part of that, there is a subprogram called GPU Direct Storage. This is, they're talking about this publicly, even though it's not generally released. We are working with them within the context of GPU Direct Storage to make NVMesh be able to work within that realm. So essentially, when you use NVMesh on this kind of server, and your GPU now needs to go and get storage, we'll actually be bringing the data directly to the GPU without having to bring it first to the CPU memory. So we'll be able to actually go, and if we're accessing storage that is remote, that is not on the box itself, we'll go to the appropriate NIC and bring the data directly from that NIC into the GPU memory space. If you're accessing local NVMe drives, we'll also do that for you. We'll bring the data directly from the NVMe drive without going through CPU memory to the GPU memory. And in that way, you'll see immediate performance benefits. So you'll be able to continue to use the same NVMesh version the same NVMesh volumes that you were using before, but you will just get increased performance. You'll be able to go to the 100 to 150 gigabytes per second instead of to the 50 gigabytes per second that you could with when going through the CPU. And in that way, you'll be able to actually go and say, okay, I can actually use multiple GPU servers. I can pool my NVMe from them. I can add on external NVMe devices and continue to provide enough storage at the speeds that I need while sharing the data, protecting the data, all the goods that NVMesh brings you. You'll be able to do it at the speeds that are required to keep the GPUs humming at the very, very highest levels. Within NVMesh 2.2, we'll be bringing this at a POC level. Why do I say POC level? Because GPU Direct in this time frame is not expected to be generally available, but we will be ready and we'll be able to let you already feel the performance improvements that you can get with this. And when GPU Direct is generally available, we will make sure that our product is also ready and generally available at that time frame as well. Okay, I think I'm actually at the end of my deck. So I'll just give a short summary and I'll leave a lot of time for Q&A. As you can probably feel, I tend to talk very, very fast, and I've done a good job of doing that today now. But again, just a short recap of where we're going, where NVMesh, where Excelero is going in the future. We really do have a very strong proven track record as a solution for hyperscalers. In the past year, we've had a lot of success with AI and with deep learning, and we've been able to bring value to multiple customers in this space, and some of them have been kind enough to talk about us publicly. And we just had a seminar a few days ago with some of the customers that were, that are those kinds of customers who have been using us for AI environments. And we continue to improve our product exactly for those kinds of environments to make it even easier to use NVMesh, even simpler for the end user, so that when they go and they install our product, they don't have to worry about the storage anymore. With our roadmap, we will continue to add value. We're bringing more and more options for our data protection, making it more widely applicable, catering to additional needs as we hear them from the market. We're also extending our options from a networking perspective. We're bringing in the option to just use vanilla TCP. We're allowing customers today, we're enabling them to use NVMe-of, the new standard NVMe over fabrics, so that they can make it very easy for them to deploy and use our product even in existing environments. We're making it easy to extend our product and to make it valuable also for non-Linux environments using our clientless integration. And we're also using SmartNICs so that you can use your environment even if you're in a multi-tenant environment and you want to be able to cater for multiple tenants in a bare metal environment so they can get as much performance as they need in the most seamless way. We're enabling that also through our integration with SmartNICs. As we increase our integration for AI use cases, it should make it, again, even easier and even simpler for our customers to roll out and use NVMesh for their AI environments. And finally, even though our erasure coding is so much better than everything out there in the market today, we're still improving it to make sure that performance is never an issue for you when you use NVMesh. And with that, I'm leaving a lot of time for questions. But before that, maybe we'll let do a second poll.
All right. Thank you so much, Yaniv. And while we have the second poll up, which inquires about your performance requirements, let me take a look at the results of the previous poll. We had half of you who are just here to learn, which is always fine. We're always seeing a lot of partners, which is awesome. Then 21% of you have less than 100 terabytes of NVMe storage, but 8% of you have more than half a petabyte. And then we had 11% between the 100 and 250, and 6% has between 250 terabytes and half a petabyte. So that for sharing this information. We will try to share the results of the second poll after the Q&A. Yes, and let's go for a few questions. We got a lot of questions. We got over 30 interesting questions, and our Q&A team, thank you everybody in that team, have been answering them at very high speed. I think I need to mention Kirill, who probably knows everybody now, or who is known by everybody now. Kirill, great job you did there. You didn't leave a lot for Yaniv, but let me take a few that were really interesting, where Yaniv may want to extend a little bit. Stefan, for example, was asking if it is possible to run an NVMesh cluster with RDMA and TCP access at the same time.
Okay, so Stefan, thanks for that awesome question. I should have actually talked about that earlier. Absolutely, yes. The idea is to be able to extend what we're currently doing. So let's say you have already our product, and now you want to be able to attach additional clients, and they're not RDMA enabled. If we had separated the two, that would be really hard to do. That's why the solution we have today is such that you can run RDMA for some clients and then TCP for other clients within the same environment and be able to access the same data and to be able to share it and get all the benefits regardless of how you're accessing the data.
All right, thank you, Yaniv. Then I had another interesting question, not super technical, but really would be good to hear your vision here as well. Vladimir was asking us if our solution is a rip out and replace to existing storage solutions, or if we can be seen as rather complementary to other storage and then to be used for specific use cases.
Well, in essence, we have customers who are using us in addition to other storage solutions. We're not a one solution takes all. And again, that goes back to being a software environment. So what we really need is, you can start out with a very small system. You could start out with just one storage server, even as small as one storage server, even though to get the benefits of the data protection and the ability to spread data across multiple nodes, you can start out with a few if you really want that data protection level to begin with. And then you can continue to grow your system. You can continue to have other storage systems next to it. We won't manage those other storage systems, but we will let them live side by side, of course. Within our environment, you can actually have multiple NVMe drives on a storage server, and you can let NVMesh just manage some of them, and you can keep some of them for other solutions, for instance, for boot drives or stuff like that. So we do know how to interact with other storage options within our environment. But we're not a solution that goes and manages all your storage pieces, integrates together. We're more, in a sense, a standalone software-defined storage solution.
Okay, thank you, Yaniv. And then we got a lot of questions around file systems. I'm not going to do them all, but I think Glenn's question was sort of summarizing it, or asking for a summary, where he's asking if we could give a bit of an overview of the various file system experiences that we've had with NVMesh.
Absolutely. Great question again. So as I mentioned throughout, so we have a very large variety of customers in a way. We have customers who generate a lot of small volumes and just put local file systems on top of them, such as XFS and ext4, and then they move their jobs around in a way. So it's sort of like almost like a Kubernetes microservices kind of environment. For some of them, even though it's not even Kubernetes, have that kind of environment. Some of them do it with Kubernetes, de facto Kubernetes. And for them, they're using local file systems. We have other customers who take it to the upstream and just generate one really, really large volume and want to share it everywhere. And then they often put a distributed file system on top of that. We've worked with various different distributed file systems, but probably the two that we work the most with, or that we see the most in the market, are BGFS from ThinkPark and Spectrum Scale from IBM. We actually, available here today also is one of our employees, our field CTO, Sven Brunner, who was the founder of ThinkPark, and has brought us great value in integrating the two together and combining the two for the most value, BGFS and NVMesh. When you put NVMesh underneath BGFS, you get the benefits of having improved performance and of being able to use erasure-coded volumes underneath for even data protection than BGFS gives out of the box. When you use IBM Spectrum Scale with NVMesh, one of the immediate benefits that you get, again, is improved erasure coding, very, very good performance also with very small block sizes, minimal CPU usage, but you can also use the SAN mode within Spectrum Scale to actually cut down on the latencies. So you have a Spectrum Scale client, it talks via the SAN mode directly with NVMesh, and doesn't have to go through an NSD, and in that way you get really great performance with your Spectrum Scale environment also. If I had to choose between the two of them, it would be very difficult. Both of them have been really, really popular on top of NVMesh, but so have the local file system. It's really, to a large degree, dependent upon your use case. And what we've seen in the AI environment is that we actually can combine the two of them. So for the different parts of the workflow within artificial intelligence, you can maybe use a shared file system for some aspects, use an NFS server for other aspects, and use a shared read-only block device, and maybe even a private block device for other aspects. So having the ability to use all of these different options within NVMesh actually allows you to refine your workflow and get the most out of any option.
All right, thank you. Then another interesting question came from Eric, who was mentioning that there are several companies out there that are selling memory-based computing, by which they are extending the memory and computing model to off-the-shelf AI apps. Eric was asking whether we compete with those and what we think of that approach for AI.
Okay. So I'll mention, I used to actually work for a company that did an in-memory database, distributed in-memory database. And it's a great solution for, it's an expensive solution. It's a great solution for some specific problems. The problem that you get with it often is that when you have a hiccup and you lose your data, then you're in dire straits from that perspective. And the cost doesn't really get offset unless the performance difference is so stark compared to what you get with a real storage solution. The flexibility and the performance level of Excelero and NVMesh is so high, and look at the numbers that you can get with GPU Direct is already so high, and the prices of flash is so much lower than main memory that there may be some very, very specific AI use cases where in-memory class, like in-memory storage is relevant, but it's going to be a relatively small niche for a much, much wider variety of problems where the performance requirements from AI are high. We can easily cater for them. And that's really sort of the heart of the market. So I'm not saying that, that those solutions don't have a place, but they're probably for some very, very unique workloads, and they're probably not very generic in that sense.
All right, thank you very much. Yaniv, there was also some confusion on one of the slides. We mentioned something about the size of logical volumes, and some people may have understood that the size of a logical volume is limited at a petabyte, while we're actually referring that it can be terabyte to petabyte scale. Do you maybe want to elaborate a little bit more and make sure nobody is confused about the scalability there?
Sure. So when I mentioned 1 petabyte, it was just an example of sort of the scale that you can go within a single volume. In essence, there's really no technical limitation that limits us, even a single volume, to 1 petabyte. We actually can go up to 2 to the power of 64 blocks of 4K, which comes to, if I remember correctly, over an exabyte. I think it's several tens of exabyte or something of the sort. So there's really no real limitation on the size of a volume. I just put it in there because in essence, we don't have anybody who's generated a volume of over a petabyte within NVMesh, over a single volume of a petabyte size within NVMesh. And so being a technical guy and not a real, and probably not a really good sales guy, I was very careful and just put in a petabyte there. But there's no real technical reason not to go way beyond that.
Okay, cool. And then completely different topic, but also an interesting question. We got a question about whether we support AMD ROM.
Yes, absolutely. So we support, of course, Intel Xeons as hosts. We support or their scale CPUs as well, and we support the AMD EPYC line as well. We have customers who have recently deployed AMD ROM also. Absolutely.
Good. And then related to this, a question that's open in our QA right now from Alexander is how much of the advantages of a single socket, oh, and someone is answering it, so it disappeared. Hold on, let me try to find that question. How much of the advantages of a single socket direct AMD architecture will be given away compared to dual socket concept where CPUs are waiting for each other also with increased latency by PCIe switches?
Okay, so I'm going to track back just a little bit here in my presentation. Oops, it ended. Okay, so I won't. I'm sorry about that. I had a diagram up earlier showing the GPU kind of environment. And one of the great things about NVMesh is that we're really tightly integrating with the hardware. So we understand what the PCI topology is. And if you use NVMesh on a target that has dual ROMs, you'll be able to, the system will help get traffic and direct traffic to the right NIC in order to get access to the drive without having to go through the CPU to CPU link. The same applies for AMD, the same applies for Intel. When failover happens, if there's a NIC that's down, maybe the system will fall back to using that route. But we'd make a lot of efforts to make sure that the data traverses the fastest link possible and direct the traffic from the network to go and enter a NIC so that it will be furnished from the same CPU as where the storage actually is, or where the drive it's trying to access actually is.
All right, good. I think we've covered the most interesting questions here. I hope everybody's questions got answered. If not, feel free to follow up with us. You can contact me, tom.layden@excelero.com, or yaniv@excelero.com, or just info@excelero.com. And we're very happy to follow up any remaining questions that you folks may have. Yaniv, thank you so much for this great presentation. To the audience, there was many of you guys, which made us very excited. So thank you so much for that as well. We will have a next webinar early June. You should be getting an email for that. It's going to be really interesting with a customer and a partner. So hoping to see you guys again there. And for now, be safe, be healthy, and enjoy the rest of your day. Have a good one. Bye-bye.